Hi all, welcome to another session of PYQ discussion class. In this class, we are going to see some questions in database management system. The first question is, which of the DBMS component ensure that concurrent execution of multiple operations on the database result into a consistent database state? Options: A. Logs, B. Buffer manager, C. File manager, D. Transaction processing system. For this question, the answer is transaction processing system, because a transaction processing system is a type of information system that collects, store, modifies and retrieve the data transactions of an enterprise. In order to qualify as a TPS, that is transaction processing system, transactions made by the system must pass the acid test. That is, the acid test refers to the following four requisites. That is, acid means atomicity, A refers to atomicity, C refers to consistency, I refers to isolation, D refers to durability. Okay. Then TPS provide rapid response, continuous availability, data integrity, ease of use. So for this question, the answer is option D, transaction processing system. I once again read the question. Which of the DBMS component ensure that the concurrent execution of multiple operations? That means we have to do multiple operations at a time on the database result into a consistent database state. The database should be consistent. If we are doing multiple operations, the database should be in concurrent consistent state, so that it is controlled by transaction processing system. For this type of system, we have some examples, that is online transaction processing, real-time transaction. Okay, I hope this clear. Moving to next question. Consider the two statements. Statement 1, relational database schema represent the logical design of the database. Statement 2, concurrent snapshot of a relation only provide the degree of the relation. In the context to the above statement, choose the correct option from the options given below. Here they have given two statements. The first statement, what they are mentioning, relational database schema represent the logical design of the database. Yes, it is true. We can check that statement 1 is really true. That is, logical design means the relational, actually logical design of the database represented by the relational database schema. But the statement 2 is wrong. Current snapshot of a relation only provide the degree of the relation. That is not true. We can check what is current snapshot. Current snapshot or instance of a relation refers to the actual data stored in the table at a specific point in time. It is a set of tuples. Okay, that is current snapshot. In the question mentioned that current snapshot, that is at the instance of time, the what the actual data stored in that particular row, that is referred to as current snapshot. But a degree of a relation is the number of attributes, that is columns. Here current snapshot refers to the rows, but degree of a relation refers to the attribute, that is columns in the relation. This is a property defined by the schema, not by the instance data. It remains constant for a given relation structure. Next, the term cardinality of a relation. Instance is the number of tuples currently in the table. Cardinality means number of rows in the table. Total number of rows in a table is referred to as cardinality. Okay, in a table we can see many rows and columns. You can see in that the number of row represent the cardinality. Okay, this varies over time. As rows we can insert, delete or update. Okay, cardinality. So here the option says that current snapshot of a relation only provide the degree of the relation. No, degree of the relation means what is that? That is cardinal number. That is degree means number of columns. Actually, snapshot means number of rows. So this option 2 is wrong. So from here we can choose answer option A is true. Moving to next question. Given the following student course schema, the student table, roll number, name, course, and the table course, you can see course number, course name, capacity, where roll number is the primary key of the relation student. That is, here we can see one table student. Here roll number is the primary key in the student table, and course number is the primary key of the relation course. Here this course number is the primary key. Attribute course name of the course take unique values only. That is course name. This here you can see course name. This course name only take unique values. Okay. Which of the following queries will find the total number of students enrolled in each course along with its course name? We have to find the total number of students enrolled in each course. That is, we have different course like computer science, maths, or MBA, MCA, like that. We have different courses. In each course, how many students enrolled? That we have to find from this table. Okay, here the query option A is given that select the course name, count star total. That is in single quotes they mentioned total. This means that count is represent another name. We are giving count to total. From student, that is student table, from student, natural join course. That is here doing natural join. Natural join means cross all the tuples we are taking. If in each table we should have same attribute. That is, here one course number is there in student table, here also course number is there, so we can do natural join by two table. And finally they are doing group by course name. That is, we have to identify each course how many students are enrolled. So that's why here group by course name. So this option A, we can say that we will get the answer total number of students um, enrolled in a course by doing natural join. Of course, we will get all the attribute and number of students enrolled in a course by doing natural join. Similarly, next statement. Select C dot course name, count star total. This is similar. Here one difference is that you can see select C dot. That is C and S are defined here, declared here. That is student table renamed as S, course table renamed as C. That is the only difference here you can see. C dot course name. That means C, the course table they are taking and the course name taken. And here one condition is applied, where condition, and applying S dot course number is equal to C dot course number. So, see, that is similar to natural join, where we have two attributes similar, then only we can do join condition. So likewise here also doing the natural join in a different way using where condition. So this way also we can take total number of students, those who are enrolled in the different courses. So option A and B are somewhat similar and they are retrieving the data similar. But in the option C, select course name, count star total from course C, where course number in select. Here one another method. This is different. That is select course number from student. Here what is doing? Course number is selecting. Course number means here we can see course number that is selecting first. That is inner query is executed first. From that they are doing this. So we can't take total number of students enrolled in this particular course. Okay, this option C is not true. Only option A and B we can select as for this question we can select option A and B only. That is the correct answer. Okay, option A and B is the correct answer. Moving to next question. It's the same query they have given, but they are giving the Some match the following questions for the same query. Same question. Here student table is given, roll number, name, course number, and another table course given, that is course number, course name, capacity. These are the attributes given, where roll number is the primary key of the relation student and the course number is the primary key of the relation course. The same question repeating. Attribute course name of the course takes unique values only. The number of record in course and student tables are. Here they mentioned that number of records in course and student table, both the table they are considering. Course table three records are there, and student table five records are there. So following relational algebra query is executed, that is R is equal to student cross, that is natural join, or we can say cardinality, like that we can say course. By doing this, what is the answer we will get? Here some from the based on this question, some table is given that you have to match. First option A, degree of a table R, that is degree means what? Number of Total number of rows in a table, is it? That is total number of tables, and total we have to, sorry, cardinality is the, in the previous question we have seen that cardinality means what? Cardinality of a relation instance is the number of tuples, that is cardinality means row. So in this question we can see here the option B, cardinality of a table, it of R, that is we have 5 and 3, total records 5 and 3, so we have to multiply that, that is 5 into 3, 15. So option B is 1. Option B 1, here you can option B1 result, here you can see the given option A. From that only you can choose, very easy way you can choose the option A if you are knowing only what is cardinality. Cardinality means number of rows in a table, that is 5 into 3 we will get 15. Next, degree of table R. Degree means total number of attributes. Here degree, I have already mentioned, degree of a relation is the number of attributes, that is number of columns. By doing natural join we will get here one student into course, we will get total 6 number of 6. Here roll number, name, course number, here course number, course name, capacity. So total number of columns we will get 6. 3 plus 3, 6 columns we will get. So the degree of a table will will be 6. Next, foreign key of a relation student. What is foreign key? Foreign key of a student. Here, student table we have roll number, name, course number. But in the course table we have course number. Here are the both are same. So in the course number is actually foreign key of which table? Foreign key of student table. Here roll number, in student table we have roll number as primary key. So course number is the foreign key. Is it? So foreign key of a relation student is course number. Foreign key of a relation course we don't have any foreign key. Okay, in primary key, in course table we don't have any foreign key. So nil. So this is the correct matching. The degree of a table is R, that is number of and R attribute. Total number of attributes in a table is 6. Cardinality of a table R is equal to 15. Foreign key of a relation of a student is course number. Foreign key of a relation course is nil. Moving to next question. Given a relation schema R, X, Y, Z, W with a functional dependencies set F is equal to X gives Y, Z implies W. All attributes take single and atomic values only. A relation, option A, relation R is in first normal form, relation R is in second normal form, primary key of a R is XZ. Choose the correct answer from the options given below. Here given a relation schema, that is x, y, z, w is the relation here. It has a functional dependency, x gives y and y, z gives w, that is, and they have given one statement that all attributes take single and atomic values only. From this statement you can confirm that option A is 100% true, that is first normal form. First normal form is in normal form contains only single and atomic values. Is it? So option A is true. From this option you can see option A in the option C. Okay. You can see the A option in C. So from first sentence itself you can simply say that answer is option C. So next you can see statement relation R is in second normal form. Now here you can see that partial dependency. That is here key is primary key of R is xz. How the xz is the primary key? Because together xz together gives these four attributes. That is xz gives x gives y, z gives w. Then y xy together gives xy xz together gives zw. So the answer is A and C only. Okay. Here the definition given that option A relation R is in first normal form, that is true, attributes are single and atomic value. Okay, relation R is in second normal form, that is false, because here partial dependency exists. Is it? No partial dependency. The second normal form allows only no partial dependency. Primary key of R is XZ, that is also true. So that's why the answer is option C. A and C is true. Here a revision table given that no, about normalization concept. In first normal form all attribute values must be atomic and single valued, no repeating groups. Okay, this is the condition for first normal form, that is all attribute values must be atomic and single valued, no repeating groups. That is ensures data is stored in a basic table structure with no complex data types or multi-valued attributes within a single cell. See, that is if we have uh, mobile number, two mobile number we have, but we will add this mobile number. We can't add mobile number in a one row, that is one column. We will distribute it in multiple values, that is single values atomically divide. Next is second normal form, that is it must be in 1NF and every non-prime attribute must be fully functionally dependent on every candidate key. That is if candidate key we have the another attribute, that is non-prime attributes fully functionally dependent depending is, that is what second normal form. Eliminate partial dependencies by ensuring non-key attribute depend on the entire candidate key, not just a part of it. In third normal form must be in second normal form and no non-prime attribute is transitively dependent on a candidate key. That is no every, that is non-prime attribute is transitively dependent on candidate key. Okay, these are the basic rules you should remember for 1NF and 2NF, 3NF. Okay, moving to next question. A transaction may be in one of the following states during its execution life cycle in concurrent execution environment. That is, this is the DBMS transaction state, that is failed, terminated, partially committed, committed, and active. These are the states we can see in the states transition in DBMS. In the given transaction in active state during its execution, find its next transition state from the options given below. That is, if now the execution is in active state, then from active states, where we can move to from these other state given from. For this question I have given a Picture here. This is the transaction states in DBMS. First active state, then partially committed state, terminated. Here another way we can from active state we can directly go into the failed state. Okay, from active state only we can go to either partially committed state or failed state. We can't directly go into committed or about a state or in terminated state. From this picture, you can says that either A or C. From active state, we can go directly into failed state or into partially committed state. Okay, the answer is either A or C. Answer. This is the correct answer. I hope this is clear. You should remember this picture, that is from active state you can go into partially committed state, then committed, terminated. Then another way is you can directly go into failed state. From partially committed state you can coming to failed state. Okay, failed and aborted, then terminated. Moving to next question. Which of the following is used to create a database schema? From this, this is very basic question. Which of the following is used to create a database schema? You can simply say data definition language. Create the schema related, all the schema related functions we can see in uh, DDL, that is data definition language. I have given some brief idea, that is database languages. We have data manipulation language, in that we can do select, insert, update, delete. Okay, but in DDL data definition language we can do create, alter, drop, truncate. Next, DCL data control language, that is grant, revoke. TCL is transaction control language, save point, rollback, commit. Okay, uh, these are the languages we have in DBMS. The correct option is DDL, that I already told, that which is used to create database schema and to define the type and the structure of the data that will be stored in a database. DDL commands we have, I have already told that create, alter, drop, truncate. Create, alter, drop, truncate. These are all the DDL commands. I hope this is clear. This class is useful to you. Thank you for watching.